In this video we are going to discuss some problems on signals, basic elementary signals, basic operations on elementary signals. We'll perform time scaling, time shifting and time folding operation on the basic signals. Okay, let us take a problem. Here we are having one problem like sketch the waveform for the signal x of t is equal to u of t plus 1 minus 2 into u of t plus u of t minus 1. And we all know u of t is nothing but a unit step function. If you people have no idea about unit step function or unit impulse or unit ramp function, please do go back to the previous video and check out what is a unit step function. Okay, all the signals are unit step function only. U of t plus 1, 2 times u of t plus u of t minus 1. Okay, these three are unit functions, unit step function. So let us take a basic unit step function u of t to perform the operation. Okay, unit step function, the value of u of t is 1 for t greater than or equal to 0, right? It starts at 0 and its amplitude is 1 till infinity. Okay, it keeps on going. This is u of t, and here we are having u of t plus 1, u of t minus 1 and 2 times u of t, which means time shifting, and here we are having amplitude scaling. Okay, 2 times u of t means we are multiplying u of t by 2, which operates on the amplitude, which affects the amplitude. 2 affects the amplitude. Since it is out of u of t, outside the u of t, we are going to multiply it by 2. Now u of t plus 1 is nothing but the signal is advanced by 1 unit. U of t minus 1 is nothing but signal is delayed by 1 unit. Let us draw u of t plus 1 first. U of t plus 1 is nothing but signal is advanced by 1 unit. Actually the signal starts at 0. Since it is advanced by 1 unit, it is going to start at minus 1. Previously it was starting at 0 and now it is starting at minus 1. Amplitude remains same, 1, okay, which is called as u of t plus 1. And second part is u of t, 2 times u of t, which is nothing but we are going to multiply the amplitude by the value 2. Previously it was 1, amplitude was 1. Now the amplitude is 2. Okay, previously the amplitude was 1, now it is 2. 2 times u of t. Okay. It starts at 0 only, 2 times u of t, and it keeps on going till infinity. Remember all these three. And last one is u of t minus 1, which is nothing but signal is delayed by 1 unit. Now the signal is delayed by 1 unit. Previously it used to start at 0, now it is delayed by 1 unit, and it means it starts at time 1. Okay, u of t minus 1, signal is delayed by 1 unit. T plus 1, signal is advanced by 1 unit. 2 times u of t, the amplitude is multiplied by the factor 2. Okay, now we are going to add these three to get x of t. Okay, let us add all the three signals. Now we got u of t plus 1 minus 2 times u of t plus u of t minus 1. Okay, you can see from these three signals, first signal starts at minus 1, second signal starts at 0, third signal starts at plus 1. Before minus 1, all the signals are having the amplitude as 0, right? It's a flat line at 0, which means, and here we are not getting any signal before minus 1. Actual signal starts at minus 1. X of t at minus 1 is let us substitute t is equal to minus 1. X of minus 1 is u of minus 1. At u of minus 1, it is amplitude is 1, 1 minus 0. U of t plus 1 minus 2 times u of t. Amplitude is 1 minus here it is 0 plus here it is 0. 1 minus 0 plus 0 is 1. Amplitude is 1. Okay. And at minus 0.5, at minus 0.5 amplitude is 1, and at minus 0.5 amplitude is 0, and at minus 0.5 amplitude is 0. 1 minus 0 plus 0, it is again 1, and it keeps on same till 0. Till 0 we are having only u of t plus 1 as the signal. We will be getting amplitude as 1 till 0. Okay. Till 0 we will be getting amplitude as 1. And at 0, amplitude is 1, here amplitude is 2, and here amplitude is 0. 1 minus 2 times u of t. 1 minus 2 is minus 1, right? 1 minus 2 is minus 1. The amplitude becomes minus 1 at t is equal to 0. Here it is plus 1 minus 2 times u of t minus 2. 1 minus 2 is minus 1, and at t is equal to 1. Sorry, at t is equal to plus 0.5. Let us consider t is equal to plus 0.5. Amplitude is 1, and at plus 0.5 amplitude is 2. 1 minus 2 is minus 1 only. We are having only these two signals till time interval t is equal to 1, because third signal starts at time interval t is equal to plus 1. Before that we are having only these two signals. So 1 minus 2 is minus 1 till t is equal to plus 1, right? Here it is minus 1 till t is equal to plus 1. We are having amplitude as minus 1. After t is equal to 1, at t is equal to 1, here we are having amplitude as 1, here we are having amplitude as 2. 1 minus 2 is minus 1, and at 1 here it is 1. 1 minus 2 plus 1. 1 minus 2 is minus 1, plus 1 is 0. So we got at t is equal to 1 as 0. And at t is equal to 2, 1, 2, 1. 1 minus 2 is minus 1, plus 1 is 0, and it keeps on going. Okay. Till infinity we are having these three signals. 1 plus 1 is 2, minus 2. We need to add these two signals and minus it by 2 times u of t. 1 plus 1 is 2, 2 minus 2 is 0. It keeps on going. Okay. This is what we were expected to get. This is x of t after the operation u of t plus 1 minus 2 times u of t plus u of t minus 1. Okay. This is the expected output for the given signal. Hope you people understand. If you people have any doubts, please do message on my comment box. We'll be connected. Okay. Let us consider a few more problems so that we can understand it even more clearly. Here we are having a problem. From the signal x of t shown in figure below, sketch x of t by 2 minus 2. X of t by 2 minus 2. We are having time shifting as well as time scaling. Which one to perform first and which one to perform second is a major confusion here. Remember, in any signals problem, firstly we go for time shifting, secondly time scaling, and lastly we go for time folding. Time shifting, time scaling and time folding are the three basic operations performed on the signals, and priority basis we go for time shifting first, second time scaling, and lastly time folding for a better and easy way to solve a problem. Okay. And now we got x of t by 2 minus 2 for this x of t signal. First thing we need to do is time shifting, which means x of t minus 2. Minus 2 is the time shifting parameter. The signal is delayed by 2 units. Previously it used to start at minus 2. Now it is delayed by 2 units. Minus 2 it used to start, delayed by 1 unit, 2 unit, and now it is going to start at t is equal to 0. It used to start at minus 2. Now the signal is delayed by minus 2, 1 unit, 2 unit. Since it is minus 2 delayed by 1 and 2 unit, it starts at 0. The signal remains the same. Whatever the signal, we are going to just move the signal, that's it. Actual signal is shifted, okay, by 2 units, 1 and 2. The amplitude remains same, amplitude is 1, which is x of t minus 2 we got. Next we need to do the time scaling. T by 2 is nothing but the signal is multiplied by, the time scale is multiplied by 2 unit. Expansion, t by 2 is nothing but the signal is expanding, which means we need to multiply the time scale by 2 unit to expand the signal. It used to start at 0, right? The signal used to start at 0. 0 into 2. 0 into 2 is 0 only. Amplitude remains same here, the signal. And 1 into 2 is 2. Now the amplitude whichever appearing at 1 is shifted till 2. Okay. And 2 into 2 is 4. The signal is to end at 2. Now it is going to end at 4. Okay. And now 3 into 2 is 6. 3 into 2 is 6. And now the signal is extended till 6. And 4 into 2 is 8. The signal ends at time interval 8. Okay. If you want to take in between signals also, here it is having 1.5. 1.5 into 2 is 3, and here we are having 1.5 signal. Okay. Only for t by 2 we are going to multiply the time scale by whatever the parameter that we are having here. Okay. So that the signal gets expanded. Hope you people understand it clearly. Now we got x of t by 2 minus 2, which is the required signal. First we are going to do the time scaling, then we are going to do the first we are going to do the time shifting, later we are going to do the time scaling. Time scaling is very much easy. Remember, if the signal is t by 2, we are going to multiply the time scale by the parameter, whatever the parameter that is having. Okay. Here we are having 2, so I multiplied the time scale by 2 times and just expanded the signal. Okay. To understand it even more clearly, let us take to understand the time scaling function clearly, let us take one more problem. Here we are having this problem. A triangular pulse signal is shown in figure below. Sketch y of t is equal to x of 3t plus x of 3t plus 2. Okay. In the previous problem it was t by 2, and now we are going to multiply it by 3 times. Okay. If we are multiplying it by 3 times means the signal is compressed, right? Now we are going to compress the signal. Here we are having x of t signal. Let us solve for it. Since y of t we got two variables, x of 3t and x of 3t plus 2, let us consider first x of 3t. Since it is multiplied by 3, we are going to divide the time scale by 3 to compress the signal. Okay. Minus 1 divided by 3, we got minus 1 by 3. 0 divided by 3, 0 divided by 3 is 0 itself. 1 divided by 3, we got 1 by 3. Okay. At minus 1 divided by 3, we got minus 1 by 3, which means we need to take the signal, whatever the signal was there at minus 1. And at 0 by 3 is 0. We need to consider whatever the signal was there at 0. Okay. The signal is compressed by minus 1 by 3 to 1 by 3. Previously it was from minus 1 to plus 1. Now the signal is between minus 1 by 3 to plus 1 by 3. Okay. Now we need to perform the second signal, x of 3t plus 2. As I said, here we are having both time shifting as well as time scaling. First thing we need to do is time shifting. Later we need to go for time scaling. For time shifting, the signal is advanced by 2 units, plus 2. We are having plus 2. The signal is advanced by 2 unit. Previously it used to start at minus 1. Now the signal is advanced by 2 unit. Okay, minus 1, minus 2, minus 3. Now the signal starts at minus 3 and ends at minus 3 and ends at minus 1. Okay. Minus 2, the amplitude is... amplitude remains same. We are not affecting the amplitude, remember. This is x of t plus 2. This is x of t plus 2. Okay. And now we need to perform time scaling. The signal is multiplied by 3 times. This signal is multiplied by 3 times. So we need to divide the time scale by 3. Minus 3 by 3 is minus 1. Minus 2 by 3 is minus 2 by 3. Minus 1 by 3 is minus 1 by 3. Okay. The signal is compressed. Okay. Minus 3 divided by 3 is minus 1. Minus 2 divided by 3 is minus 2 by 3. Minus 1 divided by 3 is minus 1 by 3. The same signal is drawn for these time scales. The amplitude remains same. Okay. This is x of 3t plus 2. Now we got x of 3t for time scale t and x of 3t plus 2. We got these two signals, x of 3t and x of 3t plus 2. We need to add these two signals to get y of t. Let us add these two signals. At minus 1, here we are having 0 and here we are having 0. It starts at minus 1. And at minus 2 by 3, here is 0, here it is 1. Minus 1, minus 2 by 3. And at minus 1 by 3, here it is 0. And here it declines to 0, minus 1 by 3. Okay. Amplitude is 1. And at minus 3, this signal gets completed, and we are left with only x of 3t. From minus 1 to minus 1 by 3, only x of 3t plus 2 performs. After minus 1 by 3, we are having only this signal, and here we are having 0. We need to place this signal from minus 1 by 3 to plus 1 by 3. Okay, amplitude remains same. This is y of t, which is nothing but x of 3t plus x of 3t plus 2. If you people have any doubts, please do message on my comment box. We'll be connected. Thank you.